The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, today eventually we're going to go on and take a look at section 11.3. But first of all, we've got some questions from 11.2. So let's take a look at those. We're going to start with problem number 10. Okay, over here. Yeah, there we go. It says determine whether the function is 1-to-1. F of x equals negative x squared minus 2x. Well, without even graphing that, there are some things that I know about it. First of all, it's a second degree equation, so the graph is going to be a parabola. Second of all, it has a leading coefficient that's negative, so a is less than 1, so it's going to be a parabola opening downwards. That does not pass the horizontal line test. Therefore, no, it is not a 1-to-1 function. All right with that?
Yes.
Okay. Next up is 24. Let's see here. Yeah, just trying to make sure I could read everything that it said. Yeah, it does. Okay. 24. The following function is 1-to-1. Find the inverse function and express it using f inverse of x notation. So f of x equals 2x cubed minus 5. So step number 1, rewrite f of x using y. Okay. Step number 2, interchange all the x's and all the y's. Step number 3, solve for y. I'm going to add 5 to both sides. X plus 5 is 2y cubed. I'm going to divide both sides by 2. Y cubed equals x plus 5 over 2. I'm going to rewrite it, putting y on the left side. Then I'm going to take the cube root of both sides. So y equals the cube root of the quantity x plus 5 over 2. Okay. Then I'm going to rewrite it using f inverse notation. And there you have it. Okay. Now, over here, notice that they wrote it like this, but you don't need to do that. You could just leave it like it is there. That should be perfectly acceptable. All right, with 24?
Yes.
Okay, let's see. Next was 26. Use composition to determine whether f of x and g of x are inverses. So if they are, we should be able to compose them in both directions and in both cases get an answer of x. So if f of x equals 5x plus 7 and g of x equals x minus 7 over 5. F composed with g of x would be f of g of x, which would be f of the quantity x minus 7 over 5. And if we're going to put that in here, so that would give us 5 times the quantity x minus 7 over 5 plus 7. The 5s would reduce out, giving us x minus 7 plus 7. The 7s would cancel, and we get x. So we're halfway home. Any questions about that process so far?
No.
All right. G composed with f of x is g of f of x, which is g of 5x plus 7. And then we're going to put that into the g. So we're going to get 5x plus 7 minus 7 all over 5. The plus 7 and the minus 7 cancel. 5x over 5, the 5s reduce out, and we get x. So yes. Good to go on? Not quite. Okay, no problem.
Yes.
All righty, let's take a look at 27. Find the inverse of the function, then graph the function and its inverse on one coordinate system. Show the, let's see, what does that say here? Show the line of symmetry on the graph. Okay. So 27, f of x equals negative 2x. So find the inverse, y equals negative 2x, x equals negative 2y. Divide both sides by negative 2. Negative x over 2 equals y, or y equals negative 1/2 x, or f inverse of x equals negative 1/2 x. So any questions about that first part?
No.
Okay, so now we want the graph where, let's see, we're going to graph this and that. So f of x equals negative 2x. What would that look like? That would go through the origin, and it would have a slope of negative 2. So it would kind of look like that. Didn't quite make the origin. And then negative 1/2 x would look like, let's see, what would that look like? That would look like this. Okay. Well, let's see. I can tell that B is wrong because the dotted line doesn't go y equals x. You see what I'm saying there? Likewise here. So this is the only one of the 3 originally given. And let's see here. This has, which one's the first one? Is this f of x equals negative 2 down to, okay, that's 1. So if f of x equals negative 2x, if it's this one, you'd go down 2 and over 1. Okay, and that looks okay. This one would be down 1 and over 2. So that one looks okay. Yeah. Now this maple generated plot, I don't have a way to do that, but I can tell that this is correct based on the information. Can you see that okay, Antonia?
Yes.
Okay, great. 28 coming up. Find the inverse of the function, then graph the function and its inverse on one coordinate system. Show the axis of symmetry on the graph. Well, okay, so f of x equals 3x plus 2, y equals 3x plus 2, x equals 3y plus 2, subtract 2, x minus 2 equals 3y, divide by 3, y equals x minus 2 over 3. So we get this. So f inverse of x, f inverse of x equals x minus 2 over 3. Which would be what? If we wrote it in slope intercept form, 1/3 x minus 2/3. So we've got this and this. And the line y equals x as well. Okay, now I've got 5 choices here. First of all, this one's wrong because the dotted line should be y equals x, so it can't be that one. It could be this one based on the dotted line. It could be this one. It can't be that one, and it can't be that one. So it's got to be either this one or this one, just looking at the green dotted line, right? Okay,
Yes.
now f of x or y equals 3x plus 2, it would have to have a y-intercept of 2. This one does. Let's see here. This one also does, and it's going up 3 and over 1. So it looks like this red line is that. Okay. But
Mhm.
let's see if the blue line is that. That would start at -2/3. Yeah, it does. Go up 1 and over 3. Yep. So it's got to be that one. All righty.
Alrighty, I got it the way you.
Okay, 29. Looks like we're doing the same thing. Find the inverse of one-to-one function, graph it, et cetera, et cetera, et cetera. Okay, so f of x equals x over 4 plus 1/4. So y equals x over 4 plus 1/4. X equals y over 4 plus 1/4. Subtract 1/4 from both sides. X minus 1/4 equals y over 4. Multiply both sides by 4. 4x minus 1 equals y. So y equals 4x minus 1. F inverse of x equals 4x minus 1. Okay?
Yeah, that's all I was gonna say. Can you get it just so that the signal activated,
So again, all 4 of these, the dotted line is correct. So that doesn't help us any. We want, let's see, this is 1/4 x plus 1/4. So it has to start at 1/4 and the slope is 1/4. And let's see, if this is 2, this is 1, this one starts at 1/4 and the slope is up 1 and over 4, up 1 over 4. It looks like this one is this blue line. What about the red or pink line? Does that fit this one? Starts at -1. Yeah, it does. And it goes up. Let's see. Slope would be 4. So 1, 2, 3, 4 and over 1. Yeah. So it's this first one. You see that?
Yeah, so basically I have to look like the -1 is the y-intercept, right?
Yes.
Okay,
Yes. Yes.
got it.
Yeah. In fact, on that informational, what I wish that they make it quicker if you knew which one was the red line and which one was the blue line, but maybe
Yeah.
they're consistent, but I just haven't figured that out yet. All right, 30. Okay. Do you think you're okay with these?
Yeah, I think so. Yeah, I think so. The way
Okay.
you just
I'm going to go ahead. I'm going to go ahead and jump to the new lesson.
Yes,
And then if you still get stuck, maybe come back this afternoon if you can. Okay.
yes.
All
I will.
right. So
Thank you.
give me a minute here. We're going to stop that and stop that and go back here. And we'll go back to just the white screen, the whiteboard screen. Okay. Can you see my grid there on the whiteboard screen?
Yes.
Okay. So this quarter, we've looked at linear functions or linear equations like y equals 2x. So that would be what? A line going through the origin with a slope of 2. I'll graph this thing here. So it looked something like that, right? Y equals 2x. We've looked at second degree equations, y equals x squared. And that would look like, let's see here, like a parabola. Like that, okay? So we've looked at linear equations, quadratic or second degree equations. Today, we're gonna look at an entirely new set of equations or functions called exponential equations or exponential functions. And they are basically in the form y equals b to the x power. So an example would be 2 to the x power. So now the variable is the exponent instead of the base. All right. Now I'm going to switch screens again. And so let's see here. Give me just a minute. And I want 7 a.m. Okay. So now you should be looking at a grid with up in the left-hand corner, it says f of x equals 2 to the x. Is that what you can see?
Yes.
All right, then we're in business. Okay, so what we're going to do here, and I think I've mentioned this before, whenever I'm starting a new kind of function, and let's say I don't really know anything about it, I tend to just try and plot some points. I use x from -3 to 3, see what I get, and then go from there. So that's what I'm going to do with this problem, okay? So if x is -3, f of -3 would be 2 to the -3 power. Recall that when you have a base raised to a negative exponent, that's 1 over the base raised to a positive exponent. So 1 over 2 cubed is 1/8. You okay with that?
Yes.
All right. If x is -2, f of -2 equals 2 to the -2 power, which is 1 over 2 squared, or 1/4. If x is -1, f of -1 equals 2 to the -1 power, which is 1 over 2 to the +1 power, which is 1/2. If x is 0, f of 0 equals 2 to the 0 power. Recall that a base, when the base is anything other than a 0, and it's raised to the 0 power, that's equal to the number 1. If x is 1, f of 1 is 2 to the 1 power, which is 2. If x is 2, f of 2 equals 2 to the 2nd power, which is 4. If x is 3, f of 3 equals 2 to the 3rd power, or 8. Now, to plot those points, -3, 1/8 is right about there. -2, 1/4 is about there, maybe moving up a little bit. -1 moves up to 1/2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. And so we get a picture oops, kind of missed it there, that looks like this. It kind of looks like half of a parabola, except that whereas on the right side, this thing keeps going up, on the left side, this thing does not go up. It gets closer and closer to the x-axis. All right. So this is a graph of an exponential function. Any questions so far?
No.
All right, I want to point out some things. This graph, so for this function, and you see that it does pass the vertical line test and the horizontal line test. Oh, so it's a one-to-one function. Okay. The domain would be what? All real numbers. So from -∞ to +∞. The range would be greater than 0, because notice that the y value, this keeps getting smaller and smaller. So if I went back here and put in -4, it would be 1/16, and -5, it would be 1/32, and -6, 1/64. Keep chipping away, but it would never reach 0. So the range is greater than 0, but the domain is all real numbers. Okay. Also, it has a y-intercept at what, 0, 1, and it has no x-intercept because it doesn't cut through the x-axis. We also say that it's increasing over its entire domain. Okay, because it's going up. As it goes from left to right, it's going up. Are you okay with that?
Yes.
All right, let's take a look at another picture. So here we have the function that we just graphed. It's already done over here in black. So f of x equals 2 to the x. Okay, it's that same picture that I just created. Now we're going to graph g of x equals 3. Oh, you know what? Wait a second. There's one more thing I want to point out. Let's go back here. Can you see that as x increases, it goes up by 1, y doubles. Every time x increases by 1, y doubles. You see that?
Yes.
Okay. So here, when the base is 3, as x increases by 1, what do you think y is going to do? Would it double? Well, let's see. Let's see what it does. Okay. All right. So if x is -3, g of -3 is 3 to the -3 power, which is 1 over 3 cubed, which is 1 over 27. Whoops, 1 over 27. Yeah. I can go in there and erase that. Okay, so 1 over 27. All right. If x is -2, g of -2 is 3 to the -2 power, which is 1 over 3 squared, which is 1/9. If x is -1, g of -1 equals 3 to the -1 power, which is 1 over 3 to the 1 power, which is 1/3. If x is 0, g of 0 equals 3 to the 0 power, which is 1. If x is 1, g to the 1 power, or g of 1, excuse me, is 3 to the 1 power, which is 3. If x is 2, g of 2 is 3 to the 2 power, which is 9. And if x is 3, g of 3 is 3 cubed, or 27. And let's see, let's graph that. -3, 1/27, -2, 1/9, -1, 1/3, 0, 1, 1/3, 2, 9, whoops, not here. 2, 9. 3/27 is off the graph, but if I graph this thing, okay. So what's happening here? As x increases by 1, y is tripling. Here it was doubling, here it's tripling. Okay, so it's climbing faster, steeper. But notice some things. So look at the red graph. The domain is all real numbers, so we can use any x value. The range is greater than 0. It's a 1-to-1 function. It has a y-intercept at 0, 1. It doesn't have an x-intercept, and it's increasing over its entire domain. So basically, all of the things that we said here and here are still true. Okay?
Okay.
And you see how this, again, triples rather than double.
Yeah.
All right. Now, let's take a look at this graph. We've still got f of x equals 2 to the x, but now we're going to change the base from a 2 to a 1/2. And let's see what happens when we do that. So h of -3 equals 1/2 to the -3 power, which is 2 over 1 to the +3 power, which is 2 cubed or 8. If x is -2, h of -2 is 1/2 to the -2 power, which is 2 over 1 to the +2 power, which is 2 squared or 4. If x is -1, h of -1 is 1/2 to the -1 power, which is 2 over 1 to the 1 power, which is 2 to the 1 power, which is 2. If x is 0, h of 0 is 1/2 to the 0 power, which is 1. If x is 1, h of 1 equals 1/2 to the 1 power, which is 1/2. If x is 2, h of 2 is 1/2 to the 2 power, which is 1 squared over 2 squared, which is 1/4. If x is 3, h of 3 is 1/2 the quantity cubed, which is 1 cubed over 2 cubed, which is 1 over 8 or 1/8. Any questions so far?
No.
So let's graph this thing. -3, 8, -2, 4, -1, 2, 0, 1, 1/2, 2, 1/4, 3 1/8. Oh. It's kind of a reflection of 2 to the x, isn't it? So what's going on here? Well, back with 2 to the x, as x increased, y doubled. Here, as x increases, y is getting cut in half because the base is 1/2. So every time x increases by 1, we take what we had, multiply it by 1/2, which cuts the value in half. So 1/2, 1/2, 1/2, 1/2, 1/2. Okay? So we still have a domain that's all real numbers. We still have a range that's greater than 0. We still have a y-intercept at 0, 1. We still have no x-intercepts, but we say that the red function here is decreasing over its entire domain. Okay? So when the base is larger than 1, it increases. When the base is smaller than 1, or I should say between 0 and 1, it decreases. Okay with that?
Yes.
All right, let's go on. How about this one? What if the base is 1? G of -3 is 1 to the -3 power, which is 1 over 1 to the +3 power, which is 1 over 1, which is 1. G of -2 is 1 to the -2 power, which is 1 over 1 squared, which is 1 over 1, which is 1. G of -1 is 1 to the -1 power, which is 1 over 1 to the 1, which is 1 over 1, which is 1. G of 0 is 1 to the 0 power, which is 1. G of 1 is 1 to the 1 power, which is 1. G of 2 is 1 squared, which is 1, and G 1 cubed is 1. Okay, so what happens for this thing? Well, y is 1 no matter what, so that's going to look like this, right? Well, that doesn't fit the pattern of exponential functions. So we say this, we say that for y equals b to the x, that's sort of a general statement in terms of an exponential equation. If the base is greater than 1, this thing opens upwards. If the base is less than 1 and greater than 0, this thing opens downwards. And b has to be greater than 0 and b cannot equal 1. So the base has to be a positive number greater than 0 but it can't equal 1 because in that case, we get this graph, which doesn't fit the pattern. Okay, so we can take any positive number for a base other than 1. Okay.
Yes.
All right. Now let's make the base a negative number and understand this is not the same as that. Here, the base is 2 with a negative sign in front. Here, the base is a negative 2. Okay. So R of negative 3 would be negative 2 to the negative 3 power, which is 1 over negative 2 cubed, which is 1 over negative 8 or negative 1/8. Okay. R of negative 2 is negative 2 to the negative 2 power, which is 1 over negative 2 to the positive 2 power, which is 1 over 4. So positive 1/4. If x is negative 1, R of negative 1 is negative 2 to the negative 1 power, which is 1 over negative 2 to the positive 1 power, which is 1 over negative 2 or negative 1/2. If x is 0, R of 0 is negative 2 to the 0 power, which is 1. If x is 1, R of 1 is negative 2 to the 1 power, which is negative 2. If x is 2, R of 2 is negative 2 to the 2 power, which is 4. And if x is 3, R of 3 is negative 2 to the 3 power, which is negative 8. Well, look what's happening here. The sign keeps changing. If we try to graph this thing, it's negative, and then it's positive, and then it's negative, and then it's positive, and then it's negative, and then it's positive. In fact, if you use a graphing calculator, it just sits there and spins. You can't do that. So basically, the base can't be negative. All right. And I already think I said that in the previous information right here. But this is just an example of what happens, why you can't do that. Okay. All right. Now, let's look at some other things. Remember with parabolas that if we had a constant out at the end, it shifted the parabola up or down. And if we had a constant inside the square, it moved it left and right. The same thing is true with an exponential equation. So this thing produces this, which is this graph, right? If I take a look at this thing and I use the same x values, all of these y values are going to be the same as these, but -3. Now, I could take 1/8 -3, and that would be like -2 and 7/8 or whatever it is. But the easier way to do this is just to say, to graph this thing, everything's going to move down 3 units. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then this thing bottoms out like this. Oops. I know that's a terrible graph. So what's changed? Well, the domain's all real numbers. Now the range, instead of being greater than 0, would be greater than -3, right? Because it doesn't cross this -3. The y-intercept is at 0, -2, and the x-intercept, well, we could calculate it. We're not going to worry about that right now, but you see it would have an x-intercept, but it's still increasing. But the whole point I'm trying to make with this is that this thing is basically this shifted down 3 units. Okay. You got that idea?
Yes.
You don't sound real sure about that.
Yeah. Can you explain me the -3? Like,
Okay, let's go back to parabolas for a minute. If I have y equals x squared and I graph that thing, it looks kind of like that, right?
yes.
But if I have y equals x squared -3, doesn't it move this graph 3 units down? So it looks like that.
Yes.
That's what we're doing here. We're taking this graph, the black graph, and moving it down 3 units to get the red graph. It's just moving it down 3 units.
Okay.
All right.
I got it. Yes.
Okay. Now what about this? This is a -3, but this is inside where the X is. So a -3 is going to move the graph that way. Oops. Plus 3 units. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So just like with a parabola, y equals x squared, y equals x minus 3 squared, this moved the parabola that way 3 units. This moves the exponential to the right 3 units. Okay.
Yeah, I got it.
Okay, great.
Thank you.
All right. So now what I want to do is go back to the regular screen. So okay. So hang on. So we should be back to just the normal whiteboard screen. Is that what you can see?
Put myself on mute for a second.
Okay, sorry.
Thank you.
All right. So here we have an equation. A equals 500 times 2/3 to the t power. One of the things that's different about this from other ones that we looked at when we graphed is that there's a number in front. So this is like y equals a times b to the x. Okay. The base is 2/3. So that means it's going to be decreasing. But there's a number out in front. Well, consider this. In fact, here, let's rewrite this as a function. Let's call it a of t equals 500 times 2/3 to the t power, where let's say t is time and a stands for the amount of radioactive material present in some situation. At the beginning of time, what time is it? Well, it's 0. What's 2/3 to the 0 power? That's 1. What's 500 times 1? That's 500. So what that says is for this equation, whatever substance we're dealing with, there's 500 of them when the time begins. But also because the base here is less than 1, it's decreasing. So it's starting at 500 and then it's going down as time goes on. Now let me actually read the entire problem to you. It says 500 grams of a radioactive material decays according to this formula. So it's telling us we're starting with 500 grams and it's decaying, meaning it's decreasing because the base for the exponent is less than 1. It says find the amount present in 10 years. So we want a of 10, which would be 500 times 2/3 to the 10 power. So on my calculator, I'm going to go 500 and then parentheses 2 divided by 3, close parentheses, and then the little caret exponent key, and then a 10. So 500 parentheses 2 divided by 3 caret 10 equals, and it says 8.6707. It says round to the nearest 1/10 of a gram. So that would be the 10th, that would round up, so 8.7 grams. So we're starting with 500 of something, and 10 years later, it's down to 8.7 grams. This is what they use to what they call carbon dating. They look at the amount of some radioactive material in a dead plant, and they use that to predict how old they think the plant is. Okay. You back, Antonia?
Yes, I'm here. I
Okay.
had to move office.
What's that?
I had to move offices.
Okay. All right. But we're on with this. Okay.
Yes.
All right. Now let's take a look at another example. This says P equals 3,745 times 0.93 to the T power. Okay. Now, when T is 0, so again, let's write it P of T, P of 0. So at the beginning, we'd have that, but a number to the 0 power is 1. So we'd have 3,745. So for this function, at the beginning, there's 3,745 of something. My next question is it increasing or is it decreasing? Well, what's the base? The base is less than 1. 0.93 is less than 1. Remember, if the base is greater than 1, it increases. If the base is between 0 and 1, it decreases. So just like the previous problem, with this one, it's decreasing. It starts with 3,745 of something, and then it's decreasing. Okay. Now, at what rate is it decreasing? 7%. Now, where did I get that? Well, 100% would be 1.00. 0.93 is 93%. So every time time increases by 1 unit, we take what was there and multiply it by 93%, 0.93, which means we lose 7%. Now let's read the problem. It says population growth. The population of North Rivers is decreasing exponentially according to this formula, where T is measured in years from the present date. Okay, so the population at the present date would be 3,745, and it's losing as time goes on. It says find the population in 6 years, 9 months. All right, time is measured in this problem in years. So 6 years, 9 months would be 6.75 years, because 9 months would be 9/12 of a year, or 0.75 years. You okay with that?
Yes.
So what we want to find is P of 6.75. So that's going to be 3,745 times 0.93 raised to the 6.75 power. So 3,745 times parentheses 0.93 close parentheses, use the little caret key, 6.75 equals, and I get 2294.6. And let's see. It doesn't say anything about what to round, but if we round it to the nearest whole person, the 6 would round up. So we'd have the population would be 2,000 population, 2,295. Okay.
Yes.
All right. We're going to look at the formula called the compound interest formula. And what that looks like is this. P stands for the principal, so that's the amount invested or the amount borrowed. R stands for the annual interest rate. T stands for time in years. A stands for, I'm going to say accumulated amount. Accumulated amount. I don't know if there's two C's at the beginning of that or not. K is the number of compoundings per year. So let me explain that briefly, how that works. You put money in a savings account, and let's say that they only compound the interest once a year, so annually. And let's say they pay 3%. So you put $100 in an account. At the end of a year, you'd make $3 interest. Boom, one time. Okay. Now, let's say that they compound the interest twice a year. So $100 at 3% annually. 6 months into that, you would get $1.50 because you'd get half of that $3. But now there's $100 plus the $1.50 in the account. So that second half of the year, you're not only going to get interest on that first $100, but you're going to get interest on that $1.50 interest you made the first 6 months. You following that? It's kind of tricky.
Yes.
The more times they compound it, the more money you're going to make. So K is the number of times compounded. If it's annually, K is 1. If it's semi-annually, K is 2. If it's quarterly, K is 4. If it's monthly, K is 12. If it's daily, K is 365, etc. Okay. All right. Now, I know we're running out of time here. I don't know if you need to get back to your work, but I'm going to just keep going and finish up these examples. If you need to leave, go ahead and check out. I'll just finish the recording and you can come back and check the end of it later. Okay. So if and when you got to go, just go ahead.
Thank you.
You bet. All right. This says compound interest. An initial deposit of $10,000. So the principal is $10,000, earns 8% interest. So the interest rate is 8%, which we convert into a decimal number. Compounded quarterly, so K is 4. How much will be in the account after 10 years? Time is 10 years. So the question is, what's the accumulated amount? All right. So our formula A equals P times 1 plus R over K raised to the KT power. A equals $10,000 times 1 plus 0.08 divided by 4, all raised to the 4 times 10 power. Now, you can put this all in your calculator at once, or you can do some simplification. For instance, if you want to take 10 times 4 and write it as 40, if you want to take 0.08 divided by 4 and write it as 0.02, and then take 1 plus 0.02 and write it as 1.02, you can do that. In other words, you could simplify this whole thing down to that. Or you can just leave it as it is without doing the pre-simplification stuff, okay? I'm going to do it as it is. So I'm going to not do the pre-simplification stuff, which if you want to do that, that's fine, but be careful. If you've got some number that doesn't come out nice and it has like a repeating number, you better go back and just use the original. So 10,000 parentheses 1 plus 0.08 divided by 4. Close the parentheses, then the little caret key, parentheses, 4 times 10, close parentheses. When I do that, I get 22080.39664. All right, this is money, and it says how much will be in the account after 10 years. Well, you can't, unless you take some tin snips to a coin and cut it into fractions, you can't, separate it off other than to the nearest penny. Since this is dollars, this would be the pennies right there. The 6 would round up, so $22,080.40 would be the amount after 10 years. All right, any questions about that?
No.
Okay, let's take a look at another problem. This says comparing interest rates. How much interest would $1,000 earn in 5 years, compounded quarterly, if the annual interest rate is 5.25%, 5.5%, sorry, my bad, which would be that. Let's see, how much more interest would be earned? Okay, so we've got that versus instead of 5%. So everything's going to be the same. Except this is going to be just 5%. Okay. So same amount of money for the same time, same number of compoundings, but the interest rate for the first one is 5.5%. For the second one is 5%. They want to know how much more interest do we get on the first one. So if we get the accumulated amount, that'll be the original principal plus the interest, right? Okay, so using the formula A equals P times 1 plus R over K to the KT power. For this first one, we'd have A equals $1,000, 1 plus 0.055 over 4 to the, let's see, 4 times 5 power. So the exponent is going to be a 20. Okay, 1,000 parentheses 1 plus 0.055 divided by 4. Close it up. Use the little caret key. Parentheses 4 times 5. Close it up. I get 1314.066502. Okay. Now we're going to go back and we're going to say A equals $1,000, 1 plus 0.05 divided by 4 to the 4 times 5 power. So our interest rate is less the second time around. Okay. Let's see, 1 plus 0.05 divided by 4 to the 4 times 5 power. I get 1282.037232. Okay, so the first one made $314.07. The second one made $282.04. You follow where I'm getting those numbers? So let's find out how much more. If we take 314.07 minus 282.04, we get 3203. So $32.03 more. So by having the same conditions, same amount invested, same amount of time, same amount of compoundings, but having a 0.5% higher interest rate over that 5-year period, we would make $32.03 more than without it. So higher interest rate, if it's in your favor, that's a good thing. Okay. All right. I've got one more problem and then I'm going to go. This says compound interest. If $1 had been invested on July 4th, 1776, so $1, that's our principal. July 4th, 1776, at 5% interest, compounded annually, so K is 1, what would it be worth July 4th, 2076? So from 1776 to 2076 is what, 300 years? Okay, so basically, we've got 1 times 1 plus 0.05 to the 1 times 300th power. Let's see what we get. Power. I get this 2273996.129, which would be $2,273,996.13. Nice chunk of change, huh? All right, that's all I've got for you for today. So for tonight, you've got section 11.3. I'm going to go ahead and stop the recording.